June 2026. 1 million new energy vehicles sold in a single month. Market penetration reached 62.8%. Nearly 2 out of every 3 new cars sold in China were electric, plug-in hybrid, or range extended. Exports that same month reached nearly 500,000 units, up 152% year over year. To put that in perspective, China sold more EVs in that 1 month than some major European countries sell in an entire year. And those vehicles are no longer staying inside China. They are showing up in European ports, Southeast Asian dealerships, Latin American streets, and Middle Eastern showrooms. For a long time, Western automakers did not take Chinese cars seriously. They were seen as cheap imitations, not real competitors. But around 2023, that perception began to crack. Independent teardowns showed that Chinese EVs were not just affordable, they were technically competitive. Sales began to climb, not just at the low end, but in the mid-range as well. The shift started to look fundamental. And that realization triggered a series of reactions. Brussels launched an anti-subsidy investigation. Then came tariffs. Washington raised EV tariffs to 100%, not simply as a trade measure, but increasingly as a matter of industrial security. The conversation shifted from cheap imports to structural threat. So here is the question everyone is trying to answer. How did an industry that barely existed 15 years ago become this disruptive? The standard answers are subsidies, industrial policy, and low labor costs. But are those explanations enough? And what actually happened? I want to walk through 3 things. How a bet that made little sense at the time helped build a market from nothing, what allowed that market to build its own momentum, and what happened beneath the surface. Let us start with the move almost nobody saw coming. In 2009, if you had asked anyone in Detroit, Stuttgart, or Tokyo which country would define the future of the automobile, China would not have been the obvious answer. Not because of bias, but because the logic of the industry made that outcome seem almost absurd. The internal combustion engine was not just a technology, it was a system, a century of accumulated engineering knowledge, manufacturing precision built over generations, supplier networks refined over decades, and brand trust that had taken lifetimes to build. For a latecomer, competing on that field was almost impossible, not because the cars were necessarily bad, but because the barriers to entry were overwhelming. So the direction began to shift, not as part of a master plan or because of a sudden breakthrough, but as a different way of directing capital. What if the future of mobility was not centered on the internal combustion powertrain? At the time, this was far from an obvious idea. Toyota was betting heavily on hybrids. The Prius had already shown that consumers would accept electrification if it was practical and reliable. European automakers remained convinced that clean diesel could protect their existing investments. Some investors were betting on hydrogen infrastructure. Battery electric vehicles were just one possibility among many, and arguably the least convincing. Battery packs came with a huge cost penalty. Range anxiety was real. Charging networks barely existed. There was almost no mass market demand. Yet electric mobility changed the rules of competition. In an EV, more of the vehicle's value shifted toward battery chemistry, power electronics, software, and advanced manufacturing. These were not necessarily simpler technologies, but they were far less established. The incumbent automakers still had enormous capital reserves, optimized factories, and powerful brands. But their deepest advantage, the very thing that had protected their margins for generations, was beginning to matter less. And that created an opening. But then came a harder question. How do you carve out space in a market already dominated by established companies? A new technology does not become an industry simply because someone chooses it. It needs something more basic, a market. And in 2009, the EV market barely existed. Consumers were not waiting for electric cars. They were expensive, unfamiliar, and inconvenient. Range anxiety was real. Charging was difficult. Battery costs were high. The product was not ready for mass adoption. So the first vehicles were introduced in controlled environments, buses, taxis, and government fleets. Not glamorous, but manageable. A bus follows a fixed route. A taxi travels predictable distances. A government fleet can return to known locations. A public transport system can plan charging around a schedule. These conditions allowed the technology to be tested, not in a laboratory, but in the real world. This early phase was not about mass adoption. It was about learning. Battery degradation, charging reliability, maintenance patterns, cold weather performance, urban energy demand. These were not problems that could be solved through research alone. They required real vehicles, real roads, real drivers, and real failures. Subsidies played an important role here, but not simply by making cars cheaper. They created time. Time for batteries to improve. Time for factories to gain experience. Time for suppliers to invest. Time for engineers to solve real problems. Time for consumers to see electric vehicles as something real rather than theoretical. Some investments failed. Some local policies were inefficient. Money was wasted. But the overall effect was that electric vehicles moved out of policy documents and into urban life. They appeared on roads. They entered fleets. They generated data. And that data forced improvement. At the same time, a different dynamic was emerging. Competition between cities and provinces. Local governments began competing to attract what they believed could become the next major automotive industry. Shenzhen moved early on electric buses. Shanghai pushed advanced manufacturing. Local competition, driven by economic self-interest, accelerated the process. Not every local bet succeeded, but the competition itself mattered. It turned EVs from a national strategy into a local economic project, and that created momentum on a scale that top-down policy alone could not have achieved. But subsidies and local competition were not the only forces at work. There was another policy that, in hindsight, may have been even more important in turning early adopters into mass-market buyers. In December 2016, China began issuing special green license plates for new energy vehicles in 5 pilot cities. For buyers in major cities, the plate offered something more valuable than a cash subsidy: easier access to the road. In Shanghai, for example, obtaining a conventional license plate could require an expensive auction or a highly competitive lottery. Green plates were often issued free of charge, allowing EV buyers to bypass those barriers. In some cities, they were also exempt from driving restrictions and received benefits such as discounted parking. One academic study estimated that the policy increased EV sales by roughly 37.8%, with the strongest effect in heavily congested cities with strict license plate controls. Together, subsidies, local competition, and the green plate policy had set the flywheel in motion. That brings us to the next part of the story. Scale. And in the world's largest automobile market, even a modest initial push could create enormous momentum. Once the flywheel began to turn, the market itself started doing more of the work, driving growth faster and further than policy alone ever could. Scale is one of the most misunderstood concepts in industrial policy. It is not just about selling more cars. It is about learning faster. Consider a company developing EVs in a small market. It sells a few thousand units. Customer feedback is limited. Production volumes remain low. Suppliers hesitate to invest. Costs fall slowly. Progress is incremental. Now consider the same company operating in a market where hundreds of thousands, or even millions of consumers are willing to try new technology. Every vehicle becomes a source of feedback. Every production problem becomes data. Every customer complaint creates pressure. Every improvement can be applied across a much larger base. This creates a cycle. More customers lead to more production. More production attracts more supplier investment. More supplier investment lowers costs. Lower costs produce better vehicles, and better vehicles attract more customers. This cycle was possible in China because its domestic automobile market was already the largest in the world before EVs became a major force. Millions of consumers were entering the market every year. Cities were expanding. A growing middle class was buying cars. Chinese brands were also changing. They were no longer seen only as cheap alternatives. Some were becoming faster, smarter, and more competitive than many observers expected. That does not mean the outcome was inevitable. A large market creates opportunity, but companies still have to build the products. They still have to compete, and in China, that competition was often brutal. By June 2026, new energy vehicles accounted for 62.8% of China's passenger vehicle retail market. EVs were no longer a niche. They were becoming the center of the market. And when a technology moves to the center of a market, the behavior of the entire industry changes. Automakers can no longer treat it as a side project. Suppliers have to adapt. Engineers have to adapt. Competitors have to adapt. The main battlefield shifts. By the middle of the 2020s, a massive domestic market had created a self-reinforcing cycle of learning, lower costs, and growing demand. That is the market logic, and it is powerful, but it is only half the story. Markets create demand. They do not manufacture batteries, refine lithium, or coordinate complex supply chains. Those capabilities had to be built in the physical world. And that is where the deeper competitive advantage began to emerge. That is what we will look at in the second part.